Hello, my name is Christopher Pogomaya. Welcome to the Chem Lab Chemistry lecture. Today we're going to be looking at chemical formula. Now, chemical formula is actually the representation of a compound using the symbols of the component what elements. Now, let's look at this compound as an example. Now, this is calcium triazo carbonate 4. Okay? Now, this is calcium tribicarbonate 4. First of all, how do we write the chemical formula for this compound? Remember we said that chemical formula is what? Representing the compound using the word symbol or the word element that makes up the word compound. So, calcium, the symbol for calcium is Ca. Now, we have triazo carbonate. Now, carbonate is what? Carbon. And then we have triazo. Triazo means we have 3 atoms of what? Oxygen. So we have O, and then 3 atoms. To show the 3 atoms, you put the 3 as a what? Subscript. This is the chemical formula for this compound, calcium triazocarbonate what? 4. Now, having said that, let's move over to what we call empirical formula. We have looked at chemical formula, so let's move on to what we call empirical formula. Now, what is empirical formula? Empirical formula is actually the what? Simplest what? Chemical formula of a compound. The simplest. The simplest. The simplest. That is the formula of a compound that shows the basic atoms or basic number of atoms that that compound is made of. Okay, that's what the empirical what formula. Now, there's a way to derive the empirical formula of a compound. Now, let's look at this example on the board. It says a certain compound on analysis yielded 2 gram carbon, 0.34 gram hydrogen, and 2.67 gram oxygen. If the relative molecular mass of the compound is 60, calculate its molecular formula. Now, you cannot calculate the molecular formula if you have not calculated the what? Empirical what? Formula. Now, to calculate molecular formula is molecular formula is what? Equal to, or is calculated as empirical formula subscript n equal to molecular mass. Okay, so if you want to calculate the molecular formula, this is what you will use. Empirical formula subscript n equal to what? Molecular what? Mass. So you now see that you will need to calculate empirical formula first before you look for what? Molecular formula. So I'm going to take us through the process on how to get the what? Empirical formula. Now, to calculate the empirical formula, we have, what elements do we have? The elements mentioned in the question, we have carbon, we have hydrogen, and we have oxygen. You write the symbol of each element that is mentioned in the question. Now, the next thing is this. You look for the mole ratio. Now, to look for the mole ratio or the number of moles is equal to reacting mass over molar mass. That's what? The number of what? Moles. That's how to calculate the number of moles. Now, so we're going to look at each element now. For carbon, in our question, they said on analysis yielded 2 gram carbon. So the amount of carbon that is reacting in this what? Compound is what? 2 grams. So we have 2.00 gram over the molar mass. That is the amount of carbon in 1 mole. is always given to us. C, carbon equal to what? 12. So we have over 12. Then hydrogen is 0.34 over 1. And then oxygen is 2.67 over 16. Now, when we solve this, we would have 2 divided by 12 will give us 0.1666666, which can be written as 0.17. Now, gram will cancel gram, so it's just 0.17. And then when we divide this, divide by 1, will give us 0.34. Then you divide this, 2.67 divided by 16. That will give us 0.166875, approximately 0.17. Now, having obtained the number of moles, among this number of moles that we have, we will divide each of them by the lowest. Now, the lowest among these three is 0.17. That's the lowest, which is the same thing as 0.17 here. So, we'll divide this one by 0.17. We'll divide 0.34 by 0.17. We'll divide 0.17 by 0.17. Now, we are looking for the number of what? Moles of each what? Element. Now, so 0.17 divided by 0.17, 0.34 divided by 0.17, 0.17 divided by 0.17. So here give us 1, here will give us 2, here will give us 1. Now we have what number of moles? 1, 2, 1. So for carbon is 1, for hydrogen is 2, for oxygen is what? 1. So we can also say the number of atoms for carbon is 1, for hydrogen is 2, for oxygen is what? 1. Having gotten to this point, we can now write the what? Empirical formula. So the empirical formula will simply be empirical formula is equal to, the first element there is what? Carbon, right? Remember we said when you want to write the formula of a compound, you use the symbol of each what? Element, right? Carbon, we have C. Now, how many atoms of carbon do we have? 1. So I could decide to put 1 as a subscript here, but there's no need to put it. If it is 1, you can just leave it. Just leave the symbol that way. Leaving the symbol that way tells you that the number of atoms is just 1. Then the next element is what? Hydrogen. Now, the number of atoms is how many? 2. So you put the 2 as a what? Subscript. Then oxygen is the next. O. The number of atoms is what? 1. So we can leave it like that. So this is the what? Empirical formula of the compound that is being analyzed in this question that was given to us. Is that clear? So the empirical formula is CH2O. CH2O. That is the what? Empirical formula. I believe that is clear now. Alright. Now, having said that, let's now move over to getting the what? Molecular formula. Welcome back. So, the molecular formula is the next thing we're going to be looking at. For the molecular formula, this is how you calculate for it. So, for the molecular formula, you write this empirical formula equal to the molecular mass. Okay? Now, the molecular mass was given to you in the question to be 60, right? So we have this is in brackets subscript N, CH2O, close bracket subscript N equal to molecular mass was what? 60. Now, for each of these atoms that we have here, we will look for their relative atomic what? Mass. So we are going to look for the relative atomic mass of each of them, add it together. Exactly. I've taught you how to look for the relative atomic mass. You can check out our video titled Relative Atomic Mass. Now, carbon is 12 as the molar mass, right? So And how many atoms of carbon do we have? 1. So we have 12 times 1 plus hydrogen is 1 as the molar mass, right? So we have 1 times how many atoms we have? 2 plus the molar mass of oxygen is what? 16. So we have 16. Now the number of atoms is 1, so that's it. Close the bracket, subscript what? N equal to 60. Now, having gotten to this point, we now solve this one out. When we solve this out, it will give us 30 n equal to 60. Opening the bracket, we have 30 n equal to what? 60. Divide both sides by 30, n is equal to 60 over 30. Therefore, n is equal to what? 2. Now, we have gotten n to be what? 2. So, the molecular formula is equal to, you go back to that empirical formula that you have there and write. Remember, we said from the beginning that empirical formula is substitute n, right? Equal to what? Molecular mass. Is it not so? Good. So, come back, molecular formula. Now, the empirical formula we got was what? CH2O. CH2O. And we said is what? Substitute n. To look for molecular what? Formula. Substitute what? N. Now, we'll rewrite CH2O. Now, n, we got n to be 2, is it not? So you put the 2 here. Now, these 2 will multiply the number of atoms of each element that is in this what? Molecular formula. These 2 will multiply the number of atoms that is in each element of this what? Molecular formula, empirical formula rather. So we have 2. The number of atoms in C is 1. So 1 times 2 is 2, right? So we have C substitute 2. Now, the number of atoms of hydrogen is 2. So these 2 out here times these 2 give us 4. So A should now become what? 4, H4. Then the number of atoms of oxygen here is 1. 1 times these 2 will give us what? O2. Now, this is the molecular formula. C subscript 2, H subscript 4, O subscript what? 2. So we have succeeded in getting the what? Molecular formula. So you see that molecular formula is not the simplest. No. It's more like, should I use the word complex or advanced? Okay? That shows a large number of atoms which is contained in each element that make up the what? Compound. So that's it for now. In our next video, we'll be looking at how we can what? Calculate, or how we can better understand atomic structure and chemical combination. I'll see you in the next video. Please don't forget to click on the subscribe button and subscribe to our channel so that when we upload any new videos, you will always be the first to know about it. Have a nice day.